Hey GED students, it's GED question of the day time. Let's take a look here. It says find the volume of a cube with a side length of 0.3 meters or 3/10 of a meter. So first of all, what kind of a problem is this? It is a volume problem, falls in the area of geometry, but like just about all the geometry on the GED, hallelujah, it's formula sheet based. So if you haven't seen the GED formula sheet yet, go ahead, Google it, print it out, get used to using it. But you can hit up that volume formula sheet, that part of the formula sheet that features volumes, and you might get a little stumped on this problem because it says find the volume of a cube. A lot of students will lose their mind like, Kate, there's no cube in this list of volume formula. You know, I see rectangular solid or rectangular prism. I see a right prism. I see a cone, a cylinder, but I don't see a cube. So first of all, let's talk about what a cube is so you know which formula to use, okay? So a cube is similar to a square in that it has the same dimensions, and we see this in this case the side length is 0.3 meters. But where a square is only two-dimensional, you know, a length and a width, volume is three-dimensional. It goes out in a third dimension. It's not flat like a piece of paper. It's like a square box. And so it's 0.3 meters out in each one of those three directions. Let me pull up a different color to put those three dimensions onto my box so you can see 1, 2, 3 dimensions. All right, because it's shaped like a box like this, even though we called it a cube, it is in the family of rectangular prisms or rectangular solids. And so I can use that first volume formula there, the volume of a rectangular prism. So let's bust that out. According to the GED, that formula is V equals length times width times height. Basically what they're telling me is to find the volume, multiply together the length, the width, and the height. That's what it means when things are shoved together. See how this L, W, and H are all shoved together with nothing in between them? In algebra, things are multiplying when they have no operation sign in between them. Okay, so now I'm going to go ahead and plug in the numbers that I know. Well, I know the length, the width, and the height. I know the three dimensions of this cube. They're all the same. They're 3/10 for the length, 3/10 for the width, and 3/10 for the height. And if I were to just plug this into my TI and do, 0.3 times 0.3, so 3/10 times 3/10 times 3/10, basically, I would get, I don't even have to put it in, I know what I would get, 0.027. And that's 27 thousandths is another way to say that, 27 thousandths of a cubic meter. So make a note to yourself if you didn't know this. Volume is measured. Volume is a three-dimensional measurement. It's how much space to fill up a three-dimensional space, So basically, it's like how many little cubes to fill up a cube or a big cube. So volume is measured in cubic units. So, for example, it could be cubic meters or cubic inches, cubic yards, cubic feet. Any distance measurement could be made into a cubic unit, okay? So now I'm saying that the volume is equal to 0.027 cubic meters. Now, this problem's done, okay? There's nothing else to do here. But I want to just draw a parallel for students about an operation we call cubing. So, we have mathematically something we call cubing. The cubing is the third power. It's a literal operation, something we do in math. To raise something to the third power is to cube it. And what I wanted to point out to you is that we have something else that would give us the same answer we got right here. If I took the number 0.3 and cubed it, and again, let's do it in our TI, okay? So to type that into your calculator, of course, you type 0.3. And then to raise it to the third power, so let me just, where will I take note of this? Here, let's do it up here. In your TI, you would type 0.3, and then to raise it to the third power, you would hit the little caret button. It looks like a little upward arrow. to get into the sky, and then you type 3 for the third power and press enter. And something interesting happens. You're going to see yourself getting the same answer. Why is that? And that's what I wanted to talk to you about, why that little floating 3 is called a cube. Why is it called a cube in the first place? Well, because what it means to raise something to the third power, it's the expanded form of saying take this number 0.3, and multiply it by itself 3 times. 3 0.3s multiplying. And it looks a lot like that, doesn't it? And indeed, that is how cube gets his name, guys, from the volume of a cube formula. If you wanted to find the volume of a cube, you'd multiply the 3 dimensions together. And guess what? They'd all be the same, because by definition, a cube's 3 dimensions are all the same. And so we have nicknamed the little floating 3 exponent as a cube, because the quick way to find the volume of the cube would just be to take the side length, or the edge, doesn't really matter, and cube it. Now that formula is not on the formula sheet. Again, we could use that rectangular prism formula, but that is how a little floating 3 gets its name. All right. If you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.